Genuine equilibrium, I told you that simultaneously we will be having equilibrium on the market, and I have talked about 2 kind of system. Okay, where you have 2 factor of production, labor and capital. Okay, used to produce 2 goods, X and Y. Okay, and it is distributed among 2 consumers. In society, we are considering that we have 2 consumers, A and B. So here we will be having simultaneous equilibrium in factor market, product market, as well as we will be having simultaneous equilibrium in the consumer market. Simultaneous equilibrium means we will be having all equilibrium together. Okay, so there is an interdependency in all 3 common market. Okay, and there is a spillover effect that we have talked about. So if there is a change in the labor market, okay, or capital market or factor market as a whole, okay, it will be affecting your product market as well as your consumer market. Okay, so on our interview, this is what we have talked about. Today we are going to move to welfare economics. So if you remember, I started by setting the very preliminary framework, okay, where I have said that welfare of a society, okay, depend upon its people, utility. Okay, and here we are considering that we have 2 consumer or 2 people in a society. Okay, so we are in a 2 by 2 by 2 framework. Just keep in mind. Okay, so welfare of a society depend upon its people, okay, or member in the society, and it depend on utility of its member. So depend on utility of consumer A and consumer B. Okay, now utility of a person, say consumer A, depends on how much unit of good X he consumed, good X consumed by person A, and how many unit of good Y consumed by person B. Okay. Similarly, utility of person B depend on how much goods he consumed A and how much unit of good Y he consumed. Okay. Apart from that, okay, apart from the quantity of the goods, okay, it also depend on the form of functional form of your utility function. What kind of functional form we have, okay, when we are looking at the utility function. Okay, so it can be in the form of, say, XA plus XB, YA, okay, XA plus YA. So suppose say total X is 400, okay, and Y is say 100, okay, and person is getting XA of 300 and YA of 50. Okay. So what will be the utility when you have utility function of this form? It will be 300 plus 50, 350. Okay. Or it can be of the form minimum of XA comma YA. So minimum of this 2 is 50, so it will be 50. Okay, it will be 350, this will be 50, or max of XA comma YA, so it will be 300, or XA into YA. Okay, so 300 into 50. Okay, so utility of a person depend on the amount of goods is consumed as well as on its utility function. Okay, similarly for person B. Okay, when we are doing Pareto Optimality criteria, okay, Pareto efficiency criteria that you can have watched in the consumption thing that I have done. Okay, there we are not comparing, okay, a person utility. We are only making points, okay, about the efficient allocation of resource, okay, whether it is production or consumption. There you have to look at a consumption point of view. Here we are going to look at simultaneous equilibrium. Okay, so for the time being, just understand that utility of a person A or any person in the society depend on the amount of goods is consumed as well as on its utility function. This point is clear? Yes, no? Okay. Now, when we look at welfare of a society, okay, so welfare of a society depend upon utility of the individual as well as what form of utility function you have. Okay, so you can have utility function of this form UA plus UB. Okay, you can have minimum of utility of A comma utility of B, or max of utility of A comma utility of B, or it can be in the form of say UA into B. Okay. So in a society where we add the utility of both person, okay, one criteria, okay, this we call Bentham criteria, okay, we no need to go into that, okay. According to him, we need to add the utility of individual in the society in order to arrive at society welfare, okay. But problem with this criteria is that if say utility of B is 0 and person A is getting the entire commodity and his utility is maximum, okay. According to this criteria, even though there is a very skewed inequality, okay, welfare of the society get maximized, okay. Here minimum, okay. Here we are looking at say A person is rich person, B person is poor person, okay. So the lowest person in the society we want to maximize, okay, the utility of person B. Then only welfare of society will be maximized, okay. This kind of thing is taken by welfare state, okay. If you remember, we have discussed in the yellow lecture, okay. Then maximum of UA comma UB, okay. So here we are looking at capitalist system, okay. So where you will find nexus between politician and business person, okay. Here you will be looking at how the resource will be allocated, okay, so that these people will get maximum utility, okay. So welfare of a society, okay, will be considered according to this person perspective, okay. And this is called the production function form, okay, that you have. And this criteria, minimum criteria, okay, is called Ronsian criteria, okay, looking at how we maximize the utility of person that is belonging to the noise section of the society, okay. So this just keep in mind, okay. The point that I want to make is that welfare of a society, okay, depend upon utility, okay, as well as form of your welfare function, okay. Now, first thing. Second thing, okay, the preliminary economic study that we start to do, okay, in that growth of GNP, okay, is considered synonymous with improvement in welfare, okay. So when GNP is growing, welfare is improving, okay. Welfare of society is improving, okay. So growth of GNP is considered to be the criteria, okay, for welfare improvement, okay. But the implicit assumption here we have is that income is evenly distributed, okay. So there is not much difference between the income of the people of the country, okay. So this is the implicit assumption when we are saying that growth of GNP have improved welfare, okay, that we are looking at output size or size of the cake, okay. So if size of the cake is increasing, so your national income is increasing, okay. If it is evenly distributed, so there are 4 individuals, okay. So each one is getting equal share, okay. When each one will get equal share, there will be improvement in welfare, okay. But the implicit assumption that income must be evenly distributed. In your macroeconomics 1 paper, you know that GNP has limitation, okay. GNP has limitation, and increase in GNP does not necessarily means that your welfare will increase, okay. Increase in GNP does not necessarily mean that your welfare will increase, okay. This we have done. Clear? This part is clear? Yes, no? Okay. Now, if increase in GNP, okay, has limitation that it is not going to increase welfare, okay. But we have to consider one very important aspect, okay. As long as economy is not producing more, okay, economy cannot distribute more, okay. Hence, once economy start to produce more, okay, then only more can be distributed, okay. I am repeating again. Only when economy will produce more, then only more can be distributed, okay. Otherwise, you cannot distribute. You cannot producing more, you cannot distribute, okay. And in order to allocate also, you need to produce more in order to allocate the resource, okay. So production, GNP basically means you are producing output, okay. So you have to produce more in order to distribute, okay. So GNP, when we are looking at GNP, okay, is a necessary criteria, a necessary condition to make improvement in social welfare. Okay. So what is GLP? When your output is increasing, okay, and you are distributing the output, okay, then it is a necessary condition for improvement in welfare. Okay, and this is not a sufficient condition. In mathematics, necessary condition means first order condition. Okay, necessary condition means first order condition. So Pareto efficient condition that we are going to do, okay, we are only going to look at necessary condition. It is a first order condition. Okay, it is a first order condition. Why it is a first order condition? Because production is taking place, okay, and that good will be distributed among consumer. Okay, we are talking about only that part. Okay, but now we have very good measure to understand welfare. Okay, how we measure the welfare in the society? Human Development Index. Okay, we are taking life expectancy, standard of living, and education also. Okay, in order to calculate welfare of the society. Okay, so we will begin. Okay, by some introduction. Okay, how this thing have started. Till now, this point is clear. What we are going to do? Yes, no. Okay. Okay. So you people have done cardinal utility analysis. Okay. So the cardinal measure. Okay. When we are talking about economic interpretation, how we measure the welfare. Okay. So the first interpretation coming from cardinal measure. Okay. Cardinal measure. So there are economic theories, okay, that believe on this cardinal measure. It is at that time, okay. So we call them cardinalist welfare economists, okay. So if you remember in the cardinal measure, okay, what we take? We take no of diminishing marginal utility of money, okay. So what this cardinalist economists are saying is that, okay, consider you have three individuals in society, say person 1, 2 and 3. Okay, you have 3 persons in society, okay, and this is the income that you have for person 1, say 1000, person 2 is 500, person 3 is 500. Okay, so if you look at the income, okay, person 1 income is double the income of person 2 and 3. Okay, so person 1 can buy double the quantity, okay, of goods than person 2 and 3. Clear? But the utility of person, okay, is not double as compared to person 2 and 3. Okay, his income is double, but his utility is not double because of diminishing marginal utility of money. Clear this part? Okay, he is able to get double quantity of output, okay, to consume than person 2 and 3, but his utility is not double. Okay, why? Because of no diminishing marginal utility of money. Okay, so what this cardinalist economics suggests is that if we are able to redistribute income from person 1 to person 2 and 3, okay, if we are able to redistribute income from person 1 to person 2 and 3, we will be able to increase social welfare. Okay. In fact, these cardinalist economists are saying is that, okay, if income is evenly distributed, then we will see that we will be having maximum social welfare. Okay, if everyone has the same amount of income or close to same amount of income, okay, say 666 something like that. Okay, so it is 2000. It is evenly distributed among these 3 persons in the society. Okay, then we will have maximum social welfare. Okay. This is a cardinalist measure or cardinalist criteria, okay, to look at social welfare. Clear? Okay. Now, Pareto criteria is an improvement over whatever criteria you have previously. I am not going into that. Okay. Why it is an improvement over the previous criteria? Okay, because it is based on ordinal approach. Okay, I am repeating again. The Pareto criteria is based on ordinal approach. Okay, what is this Pareto criteria? Okay, so Pareto criteria, when I am interpreting, don't confuse it with Pareto Optimality. Okay, Pareto criteria. Or better you write in between, then you will not make mistake. Okay, Pareto improvement criteria. Okay, Right now we just call this inefficient allocation. Okay. Okay. So what is this Pareto criteria? Okay. So if you have resource, okay, if any reorganization of resource, okay, when you are able to do reorganization of resource and you are able to make someone better off without making someone else worse off, okay, then we say Pareto improvement is possible. I am repeating again, okay. If by reorganizing resources, okay, if I am able to make someone better off without making someone else worse off, okay, then we say Pareto improvement is possible. It is same as saying that previously resource is inefficiently organized. What I am saying is that, okay, in the Pareto criteria, okay, if we are able to reorganize resources, okay, in such a way that we are able to make someone better off without making someone else worse off, okay, then we say that Pareto improvement is possible. Okay, that means that previously the resource that has been allocated, okay, is not efficiently allocated. So there is an inefficient allocation of resource. Okay, it will be clear. If it is not clear, that means you have not done the video properly. I am going to do this again. Okay, no need to worry about that. Okay, so here we are going to look at Pareto optimal criteria. Pareto efficiency or Pareto optimality. This is also called economic efficiency also, if you want to know in more precise way. Okay, this criteria we are going to look at. Okay, and this will give us necessary condition for welfare improvement. Necessary condition means first order condition. Okay, why? Because we are looking at, okay, output and how this output is going to be distributed. Okay, so we are only looking at necessary condition. Okay. So what here I am saying is that, okay, suppose you have 100, okay, this you have to distribute it between two person. Suppose I have 100, this I have to distribute it between two person A and B. Okay, so I have distributed say 40, 50. Okay, clear? So what I do is that I reorganize the resource in such a way, okay, I will be able to make person A better off. I can give him 50 and keeping the person B same 50, or I can make him say 45 and make him 55. Clear? What reorganization of resource means? Yes, no? Okay. So you are able to reorganize like your time. You got your time. Okay. Everyone got 24 hours, right? So how you people are managing your time matters. Okay. So if you reorganize yourself, okay, so you will be able to efficiently allocate resource between two things. Okay, your leisure time and your work time. That means study work. That important. I make this clear very properly in the video. That's not. Okay. So what we are saying is that, okay, any reorganization resources, okay, that make someone better off without making someone else worse off, okay, we will have Pareto improvement. Okay, that means the allocation of resource that we have previously, okay, is inefficient. Now this statement is clear? Yes, no? Clear or not? Okay. Now, what we mean by Pareto efficient? Okay, Pareto efficient basically means that, okay, it is not possible. Okay, I am saying it is not possible to make someone better without making someone else worse off. Okay, that means previously resource is allocated efficient. Okay, so we have efficient allocation of resource. That is why it is called Pareto efficient or Pareto optimal. Okay, let us start. So now we are going to start Pareto optimality, okay, or Pareto efficiency you can say. Okay, so some of the assumption that you can take is that we are looking at 2 by 2 by 2 system. So we are starting with, okay, Pareto efficiency or Pareto optimality. Okay, and here we are going to look at 3 marginal conditions. So first assumption that we are making is that it is a 2 by 2 by 2 system. Okay, two factor of production or two resources, okay, say labor and capital, used to produce two goods X and Y, distributed among two consumer A and B. Okay. Here we are only considering about allocation of resource. Okay. Here we are changing the allocation of resource. Okay, that is what we are only considering. Clear? If the allocation of resource is not efficient, okay, so what we are doing, we are changing allocation of resource to look at the efficiency aspect. Okay, here third one, production function is same, production function and technology remain same. Okay, there is no change in production function, there is no change in technology. Okay, individual consumer that we have, okay, it will maximize utility. Okay, so maximize utility, and here goods are divisible. Okay, so goods can be consumed in fraction. Okay, the purpose of every consumer, okay, is to maximize utility. Okay, here goods are divisible, and the person, okay, would like to consume both goods X and Y. It is not that you only want to consume X. Okay, so both goods will be consumed by both consumers. Firm will maximize its profit. Okay, so profit maximization is the criteria that firm will obtain. Okay, factor of production are mobile. Factor of production means you have labor and capital, or resource are mobile. Okay, in the production of X and Y. Okay, and one more assumption that I am going to take note of. For the time being, just keep this much of assumption. Okay. So given this assumption, okay, on this assumption, 2 by 2 by 2 system, we will look at one is changing by changing the allocation of resource. Okay. We will look at how we can allocate the resource efficiently. Production function technology is same. Okay. Consumer will maximize utility. Okay. They will like to consume both goods. That means both goods are normal goods. Okay. Firm will maximize their profit. Factor of production are mobile. Okay. So given on this assumption, okay, two economists we have Lerner and Hicks. Okay. These two economists, what they have done, okay, they have derived three marginal conditions. Okay. Derived three marginal conditions. Okay. So they have derived three marginal conditions, which we call first order condition, if you remember, necessary condition. Okay, first order condition, okay, for Pareto optimality, okay, or maximization of social benefit. Okay, so I am repeating again. So on this, given this assumption, okay, Lerner and Hicks, okay, had derived three marginal conditions of first order condition to look at Pareto optimality, or social maximization or welfare maximization. Okay, so maximization of social welfare. Okay, now we are going to do these three marginal conditions. Okay, based on concept or framework developed by Pareto. Okay, Pareto efficient allocation of resources, or we can say production efficiency. What are the resources we have here? We have labor and capital as resource, right? Yes or no? I have talked about resource, right? What are the resources we have? We have labor and capital as resource. Okay. What we are going to do with this resource? Okay. We are going to allocate labor and capital for the production of goods X and Y. Okay, so that we can achieve production efficiency. Okay, in the production of goods X and Y. Can everyone? Yes, no. Okay, so here we are going to allocate resource. Okay, What are our resource? It is neighbor and capital. Okay, we will allocate neighbor and capital. Okay, to produce good X and Y, and we will allocate resource neighbor and capital in such a way. Okay, so that we can achieve production efficiency. Okay. Second is efficient distribution of product among the consumer. Okay, this we call exchange efficiency or consumption efficiency. Okay, so two goods are produced, X and Y. Okay, we have to distribute these two goods, okay, among consumer A and B. Okay, so that we can achieve exchange efficiency. Okay, this is our purpose here. Okay, third is okay, optimum direction of production. Okay, this is called efficient product mix. Okay, now why we have to look at this third condition? The reason being, okay, so here, okay, producer are allocating resources in order to produce good X and Y. Okay, in order to maximize his profit. Okay, here, okay, consumer want to maximize his utility. Okay, so if consumer is taking decision independently, producer is taking decision independently. Okay, maybe producer produce say good X more than good Y. Okay, and consumer want to consume good Y more than good X. Right? Then you will be having this equilibrium. Yes or no? Clear? If X is produced more than Y, okay, and consumer want to consume Y more than X, then you will be having this equilibrium. Everyone agree? Because whatever will be produced will be consumed. It must be distributed among consumer. Okay? Once producer is producing, okay, it will be distributed. Okay? When producer is taking decision, okay, in order to produce good X and Y, okay, it may be making, okay, efficient allocation of resource, okay, neighbor and capital in the production of good X and Y. So you can have efficiency, production efficiency. Similarly, consumer may be distributing whatever is produced, okay, but the preference is more towards Y. So you may have this equilibrium, even though some efficiency you may find holding, okay, or here may or may not be holding, okay, it depends. That is why we are saying optimum direction of production. Okay, so production will be done, okay, in such a way such that these two conditions hold simultaneously. Okay, whatever producer is producing, consumer is also demanding that same thing. Okay, can you everyone? Okay, so we start with two factor production. Okay, consider an economy that had two factor of production, say neighbor and capital. Okay, and we have to allocate this resource to produce good X and Y. Clear? So we have two factor of production, neighbor and capital. Okay, we have to allocate, okay, these resources such that two goods are produced, X and Y. Okay, and we have to achieve efficiency in the production of good X and Y. Okay, this part is clear? Yes, no? Okay. Now, for simplicity, okay, take say neighbor is 500 and captain is 500. Okay, so this 500 neighbor and 500 capital, okay, I have to distribute between production of good X and Y. Okay, so you will draw the as-bar box of production, that will be square. So draw that one. This is 500. Okay, just write neighbor here. This is capital. Okay, this is axis of good X production. Similarly, you will make the for good Y. Okay, so it will be like this. If you look at for good X, capital use this direction and neighbor use this direction, and for the good Y, you will look in the opposite direction. Okay, neighbor you will look in this way and capital you will look in this way. Okay, given the initial allocation, say E. Okay, can we say that this is an efficient allocation? Okay, we have to verify that one. Okay. Given any initial allocation, okay, we know that how much of neighbor, okay, say ON1, and how much of capital OK1 is used to produce good X. Okay. Similarly, we will be knowing how much of neighbor ON2 and how much of capital OK2, okay, is used to produce good Y. Given any initial allocation of resource, we know that how much of neighbor and capital is distributed in the production of good X and Y. Now, second question is that, okay, is this allocation efficient or not? Okay, in order to know that this allocation is efficient or not, okay, we have to look at the isocount. Okay, because firm are producing output, okay, and that output we represent by isocount. So here you have neighbor, you have capital. Okay, so isocount represent, okay, different combination of input that give you equivalent of output, and higher isocount represent higher output. Okay, now, so isocount of good X will be convex to its origin. Okay, so this is isocount of good X. Okay, and at this point, okay, isocount represents that it is producing X2 unit of output. Similarly, isocount of good Y will be convex to its origin. Okay, so it produces Y2 unit of output at this point. Okay, now the question is this point efficient? Okay, then I say that consider this point to be 1. Okay, if it is not possible to increase production of one goods, okay, without reducing production of other goods, okay, then it is Pareto optimum point. But if it is possible to increase production of one goods or both goods, okay, then this point is not Pareto efficient. Okay, when we say that Pareto improvement is possible, that means this allocation of resource, okay, is inefficient. Okay, now consider point 2. Look at this point 1 and point 2. It is on the same isocount of good Y. Okay, so at point 2 I can produce more of X without reducing production of Y. Okay. Look at this point, say X3. Okay, so moving from point 1 to point 2, I am able to make Pareto improvement. Okay, by reorganization of resource, okay, I am able to produce more good X without reducing production of goods Y. Okay, so Pareto improvement is possible. That means the resource allocation that we have at point 1, say E, point E, okay, is inefficient. Okay, now look at point 3. At this point, okay, is it possible to make us improve from point 1 to point 3? Is it possible to make Pareto improvement if I move from point 1 to point 3? Yes, it is possible. Why it is possible? Point 1 and point 3 is on the same isocount of good X, but I can move good Y to higher isocount. I can move good Y to higher isocount. This is the axis of good Y. You are moving away from the axis, so this represents Y3 out. Okay, so it is possible to make, okay, reorganization of resource such that, okay, we can achieve Pareto efficient. Okay, any point in between these two, production of good X can increase because it is moving away from the origin. Similarly, production of good Y can also increase. So any point in between the lanes, okay, both good production can be increased. Okay, now look at this point 2 and 3. Okay, if I am moving towards the right of point 2, okay, production of good X will be more, but I have to reduce production of goods Y. Okay, that means Pareto efficient is not possible. Okay, now look at point 3. If I am moving, okay, this direction, what is happening? Production of Y will increase, production of X will reduce. Okay, so it is not possible to make Pareto efficient. Okay, so any tendency that we have, okay, give a Pareto efficient allocation. Okay, So we will be having family of isocount of good X and good Y. Okay. So this is for good X. Okay. Let me draw one more. Then we'll move here. So this is for good X. Say this is X1. Okay. Similarly, I will be having for Y1. That will be like this. This will be Y3. So this will be Y4. I am moving this direction. Okay. I get 1 point here. Similarly, you will be moving this direction. You will be having X4. And this is the initial I can take of Y1. Okay. This is the isocount 1 for good 1. This is 2. This is 3. This is 4. Okay. So we will be joining on this locus of point. Okay. We get contact curve. This one as well contact curve of production. Okay. What is the as per contact curve of production? Okay. It is a locus of combination of inefficient point. Okay. Where the resources are allocated in such a way. Okay. That two goods are produced at different amount and we achieve efficient allocation of resource. Clear everyone? Okay. No. From this as per contact curve of production, okay, we are going to drive production possibility front. But before that, what is the condition for production efficiency? Can anyone tell me? What is the slope of this isocount? Slope of isocount is marginal rate of technical substitution. Okay, between neighbor and captain you are doing. Okay, for good X must be equal to marginal rate of technical substitution. Okay, for good Y. Because both are tangent, so marginal rate of technical substitution for good X must be equal to marginal rate of technical substitution for good Y. Okay. So how we are going to achieve production efficiency or efficient allocation of resource? Where both isocount are tangent to each other. Okay. And by drawing the locus of combination that we have, okay, by drawing a curve, say this curve, okay, which we call contact curve, okay, we get efficient allocation of resource in the production. From this contact curve, we are going to drive production possibility front. So you are producing good X and Y. Okay. So production possibility front is showing, okay, different combination of two goods that you are going to produce, okay, by utilizing given resource and technology. The resource is given and technology is given. Okay. So it will be convex to the origin. This is your PPA, production possibility. As you are moving away from the axis of good X, what is happening? Production of good X is increasing and production of good Y is decreasing. Because when you are moving towards the origin of good Y, you are reducing the production of good Y. Okay? What it is saying? As you are moving away from good X, Y, okay? When you are increasing the production of good X, production of good Y decreases. Okay? So this is what we have. So this is Y, say 4. Okay? This is say X1. So when you are moving away from the origin, you can look at, okay, production of good X increases and production of good Y decreases. When you increase the production of good X, production of good Y decreases. Okay. So from H-bar contact curve, we drive production possibility front here. And what is the production possibility front here? Okay. It is a locus of combination of two goods, okay, X and Y, okay, that give us efficient allocation of resource given the technology and resource, whatever resource you have. This is my production possibility front here. Okay. Now this is point 1. Okay. Suppose you are here. Here you have good X, here good Y. This is production possibility front here. So you move from point 1 to point 2. What will happen when you move from point 1 to point 2? Anyone? When you move from point 1 to point 2, what will happen? Look at this one. Or here also you can look at. Output of y remains same, yes or no? But output of x increases, right? Okay. So when you are moving from point 1 to point 2, you are moving to efficient table. Okay. So when you are moving from point 1 to point 2, that means point 1 is inefficient allocation of resources. Okay. Now look at this one. When you move from point 1 to point 3, what will happen? At point 1, output of x remains same, output of y increases. At point 3, output of x remains same, output of y increases. Okay. So you are able to allocate the resource efficiently. So on point on the production possibility frontier are Pareto optimum or Pareto efficient. Okay. Any point inside this is inefficient. Okay. And how we drive this production possibility frontier? Through Edgeworth contact curve of production. Okay. In everyone. So you have Pareto improvement possible inside this point. That means resource allocation inside this PPA is inefficient. Okay. And along this PPA, one point are efficient, and we know from here is optimality. Okay. What we mean by Pareto optimality in production? Okay. So when we talking about Pareto efficiency or optimality, okay. So Pareto efficiency in production means that, okay, it is not possible to increase production of one goods, okay, without reducing production of other goods. Okay. On this point, if I want to increase production of good X, okay, from say X1 to X2, okay, what I have to do? I have to reduce production of good Y from Y4 to Y3. Okay. So in the introduction of this criteria, you have to write about the Pareto optimality in production. Okay. What is Pareto optimality in production? Okay. But I am repeating again. Pareto optimality production means that, okay, it is not possible to increase production of good X without reducing production of goods Y. If it is possible to increase production of one goods without reducing production of other goods, then the allocation is inefficient. Okay. You can give the example like point 1 is inefficient allocation of resource. By reorganization of resource, you can move to either point 2 or 3. Okay. So in this way, Pareto efficiency can be achieved. Second thing, okay, by joining on the locus of combination of tangency point of isochrone, we get Edgeworth contact curve of production. This is second point that we have to do. Okay. From third point, from the Edgeworth contact curve of production, we drive production possibility frontier. Okay. What is production possibility frontier? Okay. It is a locus of combination of two goods X and Y. Okay. That is being produced for the given resource and technology. On points along this PPF are Pareto efficient. Okay. Take for example point 1. Okay. If we move from point 1 to 2, okay, what will happen? We can increase production of X without reducing production of Y. Or other way, if we move from point 1 to 3, we can increase production of Y without reducing production of X. In between names, if you look at, okay, if we move to any point in between names, what I said, you can increase production of both X and Y. Okay. So how we can achieve production efficiency? We can achieve production efficiency only when marginal rate of technical substitution, okay, that is a slope of isochrone, okay, is equal. That means isochrones are tangent to each other. Clear? This is what we have to write in this part. Okay. Okay. Now this graph look tedious and difficult to draw. Okay, but I am telling you the process to draw the graph. Okay, it will be easy to draw the graph in the examination because here many students make mistake. Okay, when they will have to draw the graph. So you have to make only these two graphs. Okay, when you are explaining this thing. Now, how to draw the graph technique? Okay. Don't get confused. Contact of form depend on the relative price. Okay, as well as the shape of your Edgeworth box. Okay. So just follow the way I am doing. Okay, it is sufficient for you. So first draw the box. You draw 4-5 box, okay, in order to understand. So this is first thing you have to do. First draw the box, okay. Draw your eligible box first, okay, and draw the contract curve and your initial allocation resource. Can you everyone? Yes, no? Okay. Now second thing, in order to remember how to draw the graph, okay, draw the isocone. First draw x2, okay, and then draw isocone for good y. This is axis of good x, this is axis of good y. Okay? Clear? This is it. Now draw the third graph. Okay? In the third graph, you have to draw the tangency. Point number 2, point number 3 will be here. Okay? So draw that part. Okay, I am drawing with the same thing. Then in the examination you will not get confused. Make sure that you are making tangency. You are moving away from this axis, so this must be x3. This is this side, so this will be y3. Okay? So this is third graph you draw. Fourth one. Draw 2 more graphs, similar. One here. Okay? This will be say x4, this will be y1, y1, y2, y3. Okay? Similarly, draw one here. Draw it properly. Tangency should be there. Okay? So this will be y4. Because you are moving away from the axis of y, so this is y4. Okay? This is x4. Graph is easy. Everyone got it? Okay. Remember, this is point 1, this is point 2, and this is point 3. Okay? No need to explain the point. What I have said, just write that thing, that will be sufficient. Okay? From this contract curve, we derive production possibility frontier. Okay? What is production possibility frontier? It is a no cost of combination of two goods that is being produced for the given resource and technology. And on point on this production possibility frontier are efficient. Why? Because it is derived from contract curve. Okay? And contract curve is on the point, okay, where you are allocating resource efficiently. Okay? Among the production of two goods. You will be having different level of production, but it is efficient allocation of resource. This way you draw the graph. Okay? Among consumer. Okay? Efficient distribution of product among consumers, or we can say exchange efficiency. Okay. So understand the concept. Okay. You have to write the same way when what you are writing here. Okay. Don't forget to write the margin, the condition of production efficiency. That marginal rate of technical substitution, okay, for good X must be equal to marginal rate of technical substitution for good Y. Okay. This is the product efficiency condition, production efficiency condition. Okay. Now, efficient distribution of product among consumer. Okay, and we are looking at exchange economy. If you understand this concept, you can write the notes on your own. Okay. So this is your production possibility filter, right? Yes or no? Okay. What this production possibility frontier is showing? It is showing us different possibility of production. If I produce this much of Y, okay, say Y1, I can produce this much of X. If I produce this much of Y, say Y2, I can produce this much of X. Right? So it is showing us various possibility of production. Yes or no? But at a particular point in time, economy can produce only one unique combination of good X and good Y. At a particular point in time, economy can produce only one unique combination of good X and good Y. How we will know that point? Okay, we will know through producer behavior. Okay, so producer will produce that output of good X and Y that will maximize the value of output. Okay, so what is the purpose of producer? Is to maximize the value of production. Okay, this is a different possibility of production. Where actual production will take place? Okay, depend on relative price. Price of good X and price of good Y. How much good X will be produced? How much good Y will be produced? given the price, okay, or price whatever way it is determined, we are not going to that now, okay. Producer will determine how much good X and good Y will be produced, okay. Now, value of production, how we determine? We have good X and good Y, okay. Price of good X into X will give me the value of good X, okay, whatever output we are producing. Price of good Y into Y give us the value of good Y. Adding these two will be giving us value of production. This we call ISO value 9. Okay, and if you have done budget 9, okay, this is similar to budget 9 concept. Okay, so now will be negative. Okay, so now will be minus px over py, yx. Write this equation in terms of y. I have done many times. Okay, you can do it. Just add v here. Write in terms of y. You will be getting minus px over py. Okay, why it is called ISO value 9? Okay, because value remains same. This is have constant slope. This is a linear graph, right? It will have constant slope. So value remains same along this line. Okay, but if you move to the right, okay, value increases. If you move to the left, value of ISO value 9 decreases. But along ISO value 9, okay, value remains same. That is why it is called ISO value 9. Okay. So what producer will do? Producer will produce that combination that maximize value of production. So this is your ISO value 9. It is tangent to your production possibility frontier here, right? So producer will produce this much unit of X, say X star, and this much unit of Y, Y star. So this will be the actual production of X, and this will be the actual production of Y. Clear everyone? Oh, this concept I am going to use in international economics also. So that's good. So production possibility frontier, okay, PPF. So this represents different possibility of production. Okay, actual production will take place where value of production is maximized. Okay, this will be the production of good X, say X star, and this will be the production of good Y. Okay. Now, if this much of good X and this much of good Y will be produced, and consumer will demand the same amount of good X and Y, okay, then we will be having simultaneous equilibrium, right? Yes or no? If this much of good X is produced, and this much of good X is demanded, and this much of good Y is produced, this much of good Y is demanded, then we will be having simultaneous equilibrium, right? Okay. So right now I am looking everything from equilibrium perspective. Okay. So this box, okay, I am drawing it here. Say 50 unit of good X and 50 unit of good Y produced. Okay. Consider this in this way. So I am just taking this and drawing it here. Okay. So this is my consumer A axis. Then I draw the consumer B axis. Okay. Now, suppose this is initial annotation. Okay. We have two goods, X and Y, of course. Y will measure in this direction for consumer A, and X in this direction, X in this direction for consumer B, and Y in this direction. Okay. Any point on this as one box of consumption, okay, represent a particular allocation of good X and good Y for consumer A, similarly for consumer B. Clear? Okay. So consumer A is getting, say, OX1 amount of good X and OY1 amount of good Y, and consumer B is getting just one. Consumer B is getting OY1 OY2 amount of good Y. No, this is X axis. OX2 amount of good X and OY2 amount of good Y. Okay. So any point on the edge work box of consumption, okay, represent a particular allocation. Our purpose is to look at if this resource allocation is efficient or not. Okay. How we represent the preference of consumer through indifference curve. Okay. Indifference curve everybody know is a no-cost or combination of the good that give equal level of satisfaction to consumer. Right? High indifference curve represent high level of satisfaction. Okay. So this is indifference curve of consumer A. Say indifference curve 2 where in the examination. Okay. Take it from here. And thumb rule is that, okay, when indifference curve or isocon cross each other, okay, and the point that you are getting will be inefficient. Okay, when they are tangent to each other, you will be having efficiency. Okay, this is say point 1. Okay, so this much provision of or distribution of goods to consumer A, and this much distribution of goods to consumer B, is it efficient? That we have to look at. Okay. So if we move from say point 1 to point 2, okay, this is say indifference curve of consumer B. Okay, I am doing this one. If we move from point 1 to point 2, I am on the same indifference curve of consumer B. Okay, but I will be able to make consumer A better by moving it to higher indifference curve. I see it. Okay, so it is possible to make Pareto improvement by moving from point 1 to point 2. So this is inefficient. So reorganization of resource, I am able to achieve Pareto efficiency. Now look at point 3. Okay. So if I move from point 1 to point 3, it is on the same indifference curve of consumer A, IC2A, but I will be able to move our consumer B to higher indifference curve, from ICB2 to ICB3. So it is possible to make consumer B better off. In between these two, consumer A can be also make better, or consumer B can also be make better off. Okay. So by joining on just tangency point, okay, where MRS of consumer A equal to MRS of consumer B, okay, we get contact curve of consumption. Okay. You can draw the graph later on also, no problem. This is indifference curve of consumer A4. This is the origin of B. So this is indifference curve of B1. Okay. Similarly, just draw one here also. You can remove this initial allocation if you want. Okay. This is indifference curve of A, initial indifference curve because it is closer to its origin. This is indifference curve of B4. Okay. See how easy it is to draw the graph. Okay. In everyone, what we have done. Now, from this contact curve of consumption, we will derive unity possibility frontier. Okay. So, let me derive here. This part is visible to everyone? Okay. Awesome. So, you have utility of consumer A and utility of consumer B. Okay. So, from we are driving utility possibility frontier. Okay. So it is a no-cost of combination of utility of consumer A and B, okay, that we are able to achieve by efficiently allocating the resource or distributing the resource, okay, between consumer A and B. Okay. Look at this point. If I move from point 1 to point 2, I am able to increase utility of consumer A. See, it is here. I am able to increase it, okay, without reducing the utility of consumer B. Okay. Similarly, you move from point 1 to point 3. Okay. Now, how to write in the examination? You have to draw this graph. Okay. What is the exchange efficiency condition? Exchange efficiency condition is the marginal rate of substitution. Okay. For consumer A must be equal to marginal rate of substitution for consumer B. Okay. Of course, it is between good X and Y. You can write X and Y, X and Y. Write it. This is the efficiency condition. The marginal rate of substitution for consumer A equal to marginal rate of substitution for consumer B. Okay. And from this you derive this utility possibility frontier. Okay. And what is utility possibility frontier represent? It represents different combination of utility. Okay. When you have efficiency in the consumption. Okay. Now here also what you have to write? You have to write the Pareto optimality in exchange. Okay. Just you have to change it a bit. Okay. So here we are saying that we are able to achieve Pareto optimality. Okay. When it is not possible to make one consumer better off without making other consumer worse off. Okay. And allocation of resource or distribution of resource will be inefficient. Okay. If it is possible to make someone better off without making other worse off. Okay. For example, if we move from allocation 1 to 2, we are able to make consumer 2, consumer A better off without making consumer B worse off. Okay, so you can explain in this way. Concrete curve of consumption, what we derive? We derive utility possibility curve. And what is utility possibility frontier curve represent? It represent efficiency in consumption. Like production possibility frontier represent efficiency in production. This represents efficiency in consumption. Okay. On point on this utility possibility frontier are efficient allocation. Okay. This you have to write, and you have to conclude by saying that we will achieve exchange efficiency when marginal rate of substitution of consumer A equal to marginal rate of substitution of consumer B. That means indifference curve are tangent to each other. Okay. In everyone. Okay. So you have to draw these two graphs. Okay. This one need for your purpose. Okay. If you don't want to draw this one, no need to draw it. Okay. These two graphs you have to draw. This is utility possibility frontier. Or even only by drawing this graph, if you don't want to give this explanation, that is sufficient. You have to only finish this part. If you forget to put this condition and draw this graph, then it will be problem. If you don't draw this, no problem. Okay. The third one. Third one is efficient product mix or simultaneous equilibrium in production and consumption. Okay. So this is your production possibility frontier. Okay. This is your ISO value 9 that maximize the value of production. Okay. This much of X you are producing in the economy, and this much of Y you are producing. Okay. If the community indifference curve is tangent here, okay, that means community indifference curve they represent the preference of both consumer. Okay. So you will be having consumer preference. If it satisfied, I will draw one indifference curve here. Okay. So it is tangent to this 9 Px over Py. If you remember in the consumer equilibrium, you have budget 9, okay, that happens now minus Px over Py, okay, and you have indifference curve tangent to it, right? In the ordinal approach, you have done this, right? Yes or no? In microeconomics 1, okay. So here you just represent this line, remember in this way, okay. This is the price line, ISO value 9, okay. The community indifference curve is going from here, that means whatever producer are producing, okay, consumer also have preference for same kind of consumption pattern. Okay. But suppose we are not here. Okay. Community indifference curve is from here. Then what is the preference of community? How much unit of good X and why they want to consume? Production is this much of X and this much of Y. Okay, but consumer want to consume this much of X, this much is the demand of X, but production is more, and demand of Y is this much, production is less. When demand is more than production, what will happen? Price of good Y will increase. Yes or no? When demand is more than supply, price of good Y will increase. When supply is more than demand, price of good X will decrease. What is the slope of this iso value 9? In general, px over py, px over py. When this increases, this ratio will decline, or this decreases. Both factor will need to decline in your slope or the relative price ratio. This 9 will become flatter. Okay, this 9 will become flatter and it will be going from here. Okay. So ultimately we have been seeing that whatever consumer is demanding, it is being produced. Okay. Of course, there will be some adjustment taken and community indifference curve will be tangent to it. Okay. So we will be looking at the directly the equilibrium condition. Okay. So you have production possibility from here. Okay. And this is the iso value 9. This much of good X you are producing, or Y you are producing, and this much of good X you are producing. Clear everyone? Yes, no? Okay. Now, in case of simultaneous equilibrium, okay, whatever is being produced, okay, it must be demanded by the consumer also. That means consumer is also in equilibrium. Okay. So here what we are saying is that we will have simultaneous equilibrium. Okay. If production and consumption both have been the same. Whatever is being produced, it is the same thing that has been demanded by the consumer. This much of X is produced, this much of X is demanded by the consumer, this much of Y is produced, this much of Y is demanded by the consumer. Can you everyone? What is required? Okay, what is required? If we look at this one, what is required? What is the slope of PPF? Anyone? Slope of PPF. Change in Y over change in X? Yes or no? Change in Y over change in X, okay? And it is negative, means some of you know that, so I write negative. Okay. Here what we are doing is that this is product, this is also product. Okay. And so now we say marginal, so write marginal. Okay. So we are taking the resource, or we are transforming the resource from the production of Y to production of X. Okay. So the slope of PPF is called marginal rate of product transformation, or just like marginal rate of transformation. Marginal rate of transformation, MRT or MRPT. Okay. What is the slope of PPF? Slope of PPF is same, delta Y over delta X. We are taking our resource or transforming the resource from the production of Y to production of X. Okay. It is also called marginal rate of transformation. Okay. So here slope of PPF must be equal to marginal rate of substitution. Okay. So you will be having consumer here. Okay. Let me draw it. Okay. So you will be having initial location here. This I am drawing for the consumption one. Okay. So you will be having like this. You can label it. I am not labeling it. Okay. You have axis of consumer A and axis of consumer B. Okay. That is going here. This is community indifference curve that I have drawn. Okay. So what is the requirement? The marginal rate of substitution, for consumer A must be equal to marginal rate of substitution for consumer B must be equal to marginal rate of transformation. Okay. Or you can write marginal rate of product transformation, whatever you want to write. Can you everyone? So for simultaneous equilibrium in production and consumption, what we require? Slope of PPF must be equal to slope of your indifference curve. this is what you have when we are talking about simultaneous equilibrium in the production and consumption. Okay. Now, in order to understand this in a simple framework, okay, add one more assumption, because in the examination sometimes they will ask you, okay, discuss the marginal condition taking into consideration perfect competitive assumption. Okay, so net make perfect competitive assumption. Okay, this part is clear to everyone? Yes, no? Okay. Okay, before I give the perfect competitive assumption, write down the three conditions that I have given. It will be easier for me. Three marginal conditions. Okay. So first is production efficiency. So production efficiency. Okay. What is the condition? Marginal rate of technical substitution. Okay. For good X. Okay. Must be equal to marginal rate of technical substitution for good Y. Okay. That means isochrone must be tangent to each other. Okay. And this is the graph that we have drawn, if you remember. You can name it. I am not naming it, or just do it. Okay. This is axis of good Y. This is axis of good X. Okay. From this you have drawn the production possibility field. Okay. Remember this condition. Okay. Second thing, exchange efficiency or consumption efficiency. Just add exchange efficiency. We achieve by where we have marginal rate of substitution. Okay. For consumer A equal to marginal rate of substitution for consumer B. The having substitution is 2 goods. Okay. So this is the exchange efficiency, and the graph that you are drawing is the Ashburn box of consumption. Okay. Same way you can draw the graph, and if you want to drive the utility possibility front here, you can drive. Okay. Otherwise, no need to draw. Okay. Third thing, simultaneous equilibrium. This is utility possibility frontier. Okay. This is a production possibility frontier. Okay. Simultaneous equilibrium is simple. You just draw the PPA. Okay. Draw the isovalue line that maximize your production value. Okay. And inside the box, draw your this box. Okay. This box you draw it. Even if you are not drawing the commodity indifference curve, because you need to place additional analysis, don't draw it. Okay. This will be sufficient. Because you are drawing the indifference curve, okay, here of consumer A and B, okay, and here marginal rate of substitution of consumer A for good X and Y must be equal to marginal rate of substitution for B must be equal to MRT. So now must be equal. Okay, if you want to draw the commodity indifference curve that represents preference of both consumer, okay, then you can draw it. Okay, clear everyone? These three conditions don't forget to write. In examination, if you write this condition, okay, it will guarantee you that you will get some marks. Now, when we talk perfect competition, things become very easy. Okay, when we are making perfect competition assumption, okay, things become easy, and on the condition we will be looking at that it is easy to hold. Okay, how? Let me look at that thing. Okay, so in the product efficiency, okay. So what we are going to look at? We are going to look at the condition, same condition in perfect competition. Okay. So in product efficiency, if you remember, this is what sonocopy or isochrone, MRTS, margin rate of technical substitution. Okay. It must be equal to price of labor over price of capital. Because labor you are taking here, labor you are taking here and capital you are taking here. Okay. So the cost 9 that you are getting, okay, it will be PL over PK. Okay, cost, if you remember, cost is wage into labor plus gain into capital. Okay. Price of labor is wage, price of capital is R, rate of purchase. Okay. This is the for good X. Similarly, you can get the condition same for good Y. Okay. So it will be marginal rate of technical substitution for good Y. Okay. Must be equal to price of labor or price of capital. Why? In perfect competition, firms are price taker in product and factor market. Price of labor and price of capital is given. Whether it produce good X or some firm produce good Y, this is given. These two must be same. Yes or no? In perfect competition, we are able to achieve product efficiency. Can everyone? In the case of exchange of consumer, okay, you're taking good X and good Y. So the budget line that you are getting is minus Px over Py. So slope of indifference curve must be equal to Px over Py. Here also price of good X and price of good Y is given. Okay, consumer is also price taker. Okay, this price ratio must be same for consumer A and consumer B. When consumer A is maximizing, it is following this condition. Similarly, consumer B will be following the same condition. Okay, this implies that the both margin rate of substitution are same. Okay. When they talk about perfect competition, you no need to go into that detail. You can go directly here. Okay. Many students make the mistake is that they do that part. Can you everyone? When they ask about perfect competition, you have to discuss only this part. No need to drive on that thing. Is it clear? Yes, no? Okay. Don't do that part and forget to do this part. Okay, because this part is important. Okay. Now third one. Okay. Third one, what I have said is that okay, marginal rate of substitution for consumer A for good X and Y okay, must be equal to marginal rate of substitution for consumer B must be equal to MRT. Now, okay, in perfect competition, okay, price of good X must be equal to marginal cost of good X. Come equate this. Okay. Similarly, price of good Y must be equal to marginal cost of good Y. Right? MI equal to MC condition. And in perfect competition, MR is your price. Yes or no? Profit maximizing firm will be doing this. Okay, for good X and Y in perfect competition. We are in perfect competition. Okay. Now, coming to this, I have to do that part. Okay. There is no possibility that you will understand. So let me do it. Okay. This is your production possibility frontier. Okay. So initially, look at this one. On which we are taking that in order to produce one more unit of X. Whatever you are writing, one more unit. Okay. We are looking in 1 unit term. So in order to produce 1 unit, you are giving us this much of Y. Okay. In order to produce 1 extra unit of X, how much Y you are foregoing? This much of Y. Okay. So opportunity cost of producing okay 1 additional unit of X okay what it is additional cost of producing 1 additional unit of X is how much Y you are giving up. Okay, this is Y2 minus Y1, this much of Y you are giving up. Okay, what is the cost of producing 1 additional unit of X? Will be marginal cost of X. So opportunity cost of producing 1 additional unit of X is change in Y. Okay, and how I will be knowing this change in Y? By marginal cost of X. What is marginal? Additional cost of X. Can you everyone? This one? Yes, no? This part is clear? Okay. Similarly, we can look the other way around also. Okay. Opportunity cost of producing. Now I look at the other way. Okay. 1 additional unit of Y. Okay. That means this much of X I have to give up. So opportunity cost of producing 1 additional unit of Y. That means the amount of X that I am foregoing to produce 1 additional unit of Y. Okay. Represent its marginal cost. So this is marginal cost of Y. What will be the slope of my PPF? Change in Y over change in X. What is change in Y? Marginal cost of X over marginal cost of Y. Okay. Now, whether slope is increasing, decreasing, okay, that is clear to people that have done micro. Okay. Not with me, means they have done, they know it. Okay, but let me tell you, when you have concave shape, okay, as you are increasing the production of X, when you have to give up more Y, opportunity cost increases. Okay, opportunity cost increases. That means marginal cost of X increases. Okay, look at this one. Now you are giving up more of y. Previously you are giving up little of y. Now you are giving up more of y. Previously you are giving very small amount of y to produce one additional unit of x. Okay. So when you are giving up more of y, what happens? Opportunity cost increases. Yes or no? Because this shows that you are putting up to produce x, you can put up to produce y and can produce more of y. Okay? But you want to produce more of x, so opportunity cost increases. Okay? So when you have concave shape, okay, you will be having increasing opportunity cost. Okay? If you don't get it in this way, understand in this way. Okay? Look at this curve. Here you write marginal cost of x, here you write x, here you write marginal cost of y, you write y here. Okay? This is just a background. Okay? Don't worry, you can be clear. Okay? So when you are increasing production of x, marginal cost is increasing, right? Yes or no? Everyone clear? When you increase the production of x, so this numerator will increase. So when you increase the production of x, production of y reduces. Production of y reduces. Okay? So marginal cost of y also reduces. Okay? So when marginal cost of y reduces, the denominator reduces. One is decreasing, other is increasing. So this will be increasing. So SNOP is increasing. And SNOP represent opportunity cost or trade-off, you can say. SNOP represent opportunity cost or trade-off. Okay? And it is increasing. That is why when you have concave PPF, it is called increasing opportunity cost. Okay? When you are increasing opportunity cost, it is concave to the origin. Okay? For the time being, this is not important that much. Okay? What is important for me? Okay? Now let me put it. So MRT, okay, MRT, okay, is the SNOP of your PPF, which is nothing but marginal cost of x over marginal cost of y. Okay, this is what I want to make. Okay, this is my PPF, production possibility frontier. SNOP of this production possibility frontier is called marginal rate of product transformation or marginal rate of transformation. Okay, with x and y. I am doing isovalue line. What is the SNOP of this isovalue line? Minus px over py. Okay, so it is tangent here. So MRT, okay, must be equal to SNOP of this isovalue line. Then only value of production will be maximized. This must be equal to px over py. Right? So when you take the ratio of this one, what you get? MCX over MCY equal to px over py. Yes or no? Everyone got it? Okay? Okay? Now, okay? I am coming to the conclusion. Look at this one. Okay? Consumer is in equilibrium when marginal rate of substitution equal to px over py. Okay? If this is the price ratio and this is equal to the SNOP of PPF, okay? Then on this 3 must be equal and this px over py. Okay? Then we will be getting simultaneous equilibrium in consumer and production, in consumption and production. Clear? Yes, no? These two things is equal to px over py. I have just shown you that MRT, marginal rate of transformation, is also equal to px over py. Okay? If you take the ratio of these two, px over py will be equal to mcx over mcy. Okay? What is margin cost of x over margin cost of y? It is a SNOP of PPF. There you get tangency. Okay? And here you have drawing the indifference curve of the consumer. Okay? The SNOP of both consumer indifference curve is equal to SNOP of your PPF, production possibility frontier, and that is equal to the price ratio. Okay? Can everyone? In this way, in perfect competition, we get equilibrium. Okay. Now, we have done the Pareto efficient criteria. Okay. Okay. But there is an issue with this criteria. Okay. If you have looked at it, okay. The first issue that I have talked about, that it is looking at only the necessary condition. Okay. And you people know that, okay, increase in GNP does not necessarily mean that welfare will improve. Okay. So it is a necessary criteria. it is an important criteria, but one is necessary, not a sufficient condition for improvement in welfare. Okay. When we are doing this, looking at this efficiency condition, let me draw the graph, then it will be clear. This is the limitation of criticism of the, this method. Okay. Of looking at source and optimum. Okay. So look at this one. This is indifference curve of consumer A. This is indifference curve of consumer B. Okay. And there is some point, say K. This is point 2. This is point 1. This is origin of A, origin of B. Okay. So moving from point 1 to point 2. Okay. Consumer A will prefer. Yes or no? Consumer A will prefer moving from point A to point 2. Why? Because he will be on higher indifference curve. Clear? This part is clear? Yes, no? Okay. This point K, even though this is not optimum, this point K is not optimum. Okay. Whether tangency will take place here or not, okay, we will be knowing when we will be drawing the indifference curve, and it will be outside the tangency, because on the tangency point will be on this contact curve. Okay, so this point will be not optimum. Okay, that is we know. It will be inefficient, you can say. Okay, because on the efficient point will be on this contact curve. Okay, this point will be preferred by whom? Consumer B. Why? Because consumer B will be on the higher indifference curve here, right? Yes or no? If I am drawing the indifference curve of consumer B, he will be on the higher indifference curve. Everyone understand what I am saying? Okay, but this is not optimum. Okay, so we cannot compare an efficient point with an inefficient point. That means we cannot make interpersonal comparison. Okay, whether this is optimum or this one is the desirable point. So this is efficient point, we know. This is inefficient point. But consumer will prefer this point than the efficient point. Okay, we cannot make interpersonal comparison when we are using Pareto efficient criteria. Okay. Now, here we are talking that on this point is efficient. Okay. This point is also efficient, where consumer A is getting nothing and consumer B is getting on the thing. Okay. So here distribution aspect is not considered. Okay. And which outcome is best, we don't know. Whether it is this outcome is best or this one is best, we don't know. Which one is saying that the allocation along this contact curve is efficient. Okay, but which is the best allocation? We need to consider the utility function of consumer B and consumer A, right? Yes or no? We have to look at the utility function of consumer A and B, apart from how much good they are consuming, right? In everyone? Okay. So here we does not require equitable distribution to achieve efficiency. Income inequality aspect is not looked at. Okay. There exists inequality. Okay. So on this aspect is not considered in Pareto efficiency. Okay. There is an improvement over the Pareto efficiency criteria that is not inusable. That we call Kando-Hicks criteria. Okay. Then in the Kando-Hicks criteria there is also an issue that has been solved by Sitovarsky. Okay. So there is Sitovarsky criteria that we look at. Okay. For your syllabus, we just have to stick to this necessary condition of social optimality. Okay. Or you can say first order condition. Okay. Of making decision how we can maximize social welfare. Okay. So I stop here and this completes our syllabus. Thank you.